Hello and welcome everyone to today's coding challenge. This is the problem of the day of 12 June 2K25 on Geeks for Geeks. The question is K closest elements, which states that we have given a sorted array ARR of unique integers and an integer K as well, and a target value, and we have to return k closest elements to that target value from array, excluding the target itself if it exists in the array. A element A is closer to x than b itself when the distance between this a and x is actually smaller than that of the distance between this b and x, or in case of any tie, that means if the distance between x and a is actually equal to the distance between x and b, then we have to return the largest element between a and b. And finally we have to return the k closest element in order of closeness. So let us look at this example number 1. We have given ARR equals to 1, 3, 4, 10, 12, k equals to 2 and x equals to 4. And if we look out this example, we can find out that distance between this 1 and 4 is actually 3, while distance between 3 and 4 is actually 1. So that means 3 is actually closer to this 4 rather than this 1. This 4 is equals to this 4, so we have to exclude this and we did not count this. Distance between this 10 and 4 is actually 6, which is largest among this 1 and 3, and distance between this 12 and 4 is actually 8, which is largest among all these points. So the two closest elements to this target value is actually this 3, which have only distance 1 from this point, and this one which is have a distance of 3 from this point. So what will be the intuition behind this problem to solve this is something like binary search as well, and the concept of a priority queue as well. We can binary search for the closest elements from a target in its left and in its right as well, because the ARR given to us is actually in a sorted order. Also we can use the concept of priority queue in this, because this is something like finding k most frequent elements, or like k nearest elements to this target value. So let us visualize the intuition behind this problem to solve it from the priority queue. Look at this example number 1 and look at this code first here. Think of some priority queue that can store a pair of int, and where the first part of a pair is actually the difference between the ARR of I and this target value, and the second part is actually the value itself. And what will be the comparator function for this priority queue is, if the difference is actually same for any two elements, then we have to prioritize the element that have the largest value, and if the difference is actually not the same, then we have to prioritize the value that have the smallest or the smaller difference among these two. So let us dry run our code first. first declare a priority queue with this type of custom comparator function, and starts a loop from I equals to 0, that means from here, and find out the difference between array of I and this point 4 or the target. And as we can see that the difference or the absolute difference between these 2 points is actually 3, and this 3 is not equals to 0 because this if is actually here to tackle the condition of the element itself. If the difference is actually 0, that means the target values itself exist in the array and we have to exclude that. We don't want to put that inside our priority queue. So this 3 is actually not present in this, and this is actually not equal to 0 as well, so we have to put that inside our priority queue. So let us put this 3 with the value itself inside our priority queue, this 3 comma 1, and this is our front of this priority queue until now. Our I gets incremented and points to this 3. Now the absolute difference between this ARR of I and this 4 is actually 1, and 1 is actually not equal to 0, so we have to put that inside our priority queue, and the custom comparator now compares this 1 comma 3 to this 3 comma 1, and whoever has the smallest difference will be given as the higher priority. So 1 is actually smaller, so that has given the higher priority. So 1 is actually placed above this 3, 1 comma 3. Now our I gets incremented and points to this 4, and as we can see that this 4 minus 4 is actually 0, and that means the target value is itself present in this, and in this case we have to just continue our loop and forget about the successing lines of code here. So this will force this for loop to increment or to jump directly on the next iteration. So this time our I gets incremented from this 4 to this 10, and now distance or difference between this 10 and 4 is actually 6, and 6 is actually not present in this, and as we can see that 6 is actually larger to this 1 and 3, so that this 6 has the lowest priority among these two, so this is placed below this 1 and 3, 6 comma 10. Our I gets incremented again and points to this 12. The distance between or the absolute difference between this 12 and 4 is this time 8 now, and 8 is actually not present in this and has the maximum difference, and that is why it is given as the lowest priority and can be placed below this 1 3 6 with 8 comma 12. Now let us make a k size array, and in this case it is 2 size, and our index will actually points to this, that is in idx is equals to 0, while k minus minus is equals to 0, and we have also have to check that priority queue is not empty, and this time this k is actually 2. This time this k is actually 2, and this 2 minus minus is greater than equals to 0, This is a post decrement, so this condition is checked by 2 is greater than equals to 0, and after checking this condition this k gets decremented. That means k is 1 and this condition is true, that is 2 is greater than equals to 0, and priority queue is not empty as well, so we have to pop out our value from this. And while we popped out this whole array or a pair of integer is pulled out from this priority queue, but we only have to look out for the value itself, that is 3, and we have to put that inside our answer and update our index. That means index is now points towards this, and this gets pulls out from the priority queue itself, and our front part of priority queue is now this 3 comma 1. K is 1 now, that means this 1 minus minus is greater than 0 or not, and as we know this is a post decrement, so first the condition gets checked and then this k gets decremented from 1 to 0, and we can find that 1 is actually greater than equals to 0, and this priority queue is empty. This priority queue is not empty as well, so we have to pull out this, and first we have to save this value, and that is 1, put that inside our answer and pull out this front. Now the front is this, but this time k is equals to 0, that means 0 minus minus is actually not equals greater than 0, so this while loop gets terminated, and finally we have to return our answer to of example number 1. Now this is one of the approaches of priority queuing. So let us code this and look at the code if it is correct or not. Let us first initiate a priority queue that can take a integer array, and in C++ you can use a pair of int of int. Let us give this priority queue a custom comparator, that means if difference is actually same, then prioritize the larger value among all, and if it is not, then prioritize the minimum difference among all. And this priority queue will intake elements as this. Initiate our answer of size k, starts a loop from I equals to 0 till I is less than n. Find out the difference between absolute difference, I can say that between array of I minus the target value, and let us check if this difference equals to 0, that means whether the target value is itself present inside the array or not. If it is, then just continue, and if it is not, then add current difference with its value inside the priority queue. Now iterate over priority queue k times and also check if the priority queue is empty or not. Pull out the value from priority queue because we don't want to do anything with that difference, we only need the value. Pull out this front part and save our answer into and finally we have to this is actually area of I, finally we have to return our answer array. Now let us check if it is running fine or not. It has some issues. Yes, we forget to find out the array length. Now let us run this. Yes, it is running fine, so let us submit this. It is running fine and it passes all the test cases. So I guess you all understand the concept. So thank you so much guys, and keep learning, and do like and subscribe to this YouTube channel. Thank you guys.